permutation and combinations. And before we go that, let's check the meaning of permutations. And if you are new to this channel, please subscribe, share, and like, comment, please. Now, what's the meaning of permutation? Permutation is a possible arrangement of n distinct objects taken from R with attention given to the order of arrangement from R. With attention, let me write it. With attentions given to the order of arrangement. Now, what is permutation again? I say permutation is a possible arrangement of n distinct objects taken from R. Let's say I have 10 students and I want to give 3 scholarships. So if I want to give 3 scholarships, that means 3 scholarships can only be given to 3 students out of 10 students, because I cannot give it to all the 10 students. So what will I do is that I will not just go there and form and pick out the 3 students like that, because I have to consider the remaining students. In a situation where I'm considering the remaining students also, that is permutation. That means I will now look for possible ways of picking those 3 students that I want to give that scholarship to. So the possible way of giving those 3 students is what we call permutations. I need to apply a principle called permutations. Now, that's why I say permutation is a possible arrangement of n distinct, that means those three distinct objects taken from R, because I have to take them away from that thing. With attention given to the order of arrangement, I have to give attention to the order of arrangement. Now, imagine I have 3 objects, A, B, C. Now, if they ask me that the possible way of arranging these 3 objects A, B, C, initially we can use tree diagrams. But because that tree diagram cannot be continually using it, that's why there's a new method. But before we apply formula of permutations, let us take a look at that tree diagrams. That tree diagram, let's say I have 3 objects, and possible way of arranging these 3 objects, I can use tree diagrams. B, A, and B, C. You can put it here. A and for this line, B for this line, C. Now, possible way of arranging, I can say A, B, C. That's A, B, C. I can also say A, C, B, A, C, B. Now let's come to B. I can say B, A, C, B, A, C. For B again, I can say B, C, A, B, C, A. Now for C, I can say C, A, B, and C, A, B. I can say C, B, A, C, B, A. So these are the possible arrangements for these 3 distinct objects. So that means for 3 distinct objects, I have how many possible arrangements? 1, 2, 3, 4, 5, 6. I have 6 ways. That's a possible arrangement for these 3 distinct objects. Now, we can do the tree diagram for 4 objects also, 5 objects also, according to these patterns. Now, but that will be stressful and and it will be consuming time. That is why mathematicians came up with this word called factorial. Came up with this word called factorial. Now, if I have these three, possible way of arrangement, I will just say 3 factorial. This thing is factorial. Now, factorial, how do we go about it? If I take these 3 first, you take any number here first. You now be subtracting, you subtract 1 from it as if you are going back. -1, -2, until you can no longer subtract anything from it. Because if you subtract -3, it will end to 0. And we don't count 0 here. That will be 3 into bracket. 3 minus 1, 3 minus 2, factorial. You have to put factorial to where you are stopping. Now, why I don't say 3 minus 3? Because 3 minus 3 is 0, and we must not enter 0. That means 3 into bracket. 3 minus 1, that is 2. And 3 minus 2, that is 1. And 3 times 2, 6. Because 1 factorial is still 1. Anywhere you see 1 factorial is 1. So 3 times 2, 6. 1 factorial is 1. And 6 times 1, that is 6. 6 ways. Can you see? They have the same thing. So instead of using the 3 diagrams, that's why they came up with this thing called factorial. Factorial. Now, let's take a look at some important things in factorial. Don't forget the difference that is between permutation and combination is that permutation gives attention to the order of arrangement. That is, permutation is not just taking those 3 objects out of 7 objects just like that, without considering orders. But in combinations, they will just come and pick the 3 they want to give their scholarships, and they won't give attention to the order of arrangement. And these permutations, if you look at the 3 diagrams, you will see that it's without repetition. We don't repeat letters. There's no that but it can be in form of repetition at times. It can be in form of non-repetitions. When we get to some questions, we start checking into those things I said. Now, some important factorial. Now, 1 factorial is 1. 0 factorial is 1. Like 2 factorial, that will be 2 times 1. I told you are going back. When you say 2, open bracket, 2 minus 1, that is 1. That is 2 times 1, that is 2. And so on and so forth. When we have n factorial will be n, open bracket, don't forget, n minus 1, n minus 2, and so forth. N minus 3. You can go like that. So for just be counting to the back, especially when it's in n. So that is for permutation. Now, what's not the formula for? The formula for permutation. Let's say we take n objects from R. That's going to be what? N permutation R. N permutation R. I'm taking n objects. Possible way of taking n objects from the number of R objects. That means the total